We talked a moment ago about the background blob and the fact that it has two holes in it which represented the foreground objects. Let's look at this much more complicated example. A binary image, large number of blobs, blobs with holes in them, and then blobs within the holes within the blobs, and so on. If we apply the connectivity analysis, we're able to label all of these individual blobs. It doesn't matter whether the blobs are black or white, they are distinct coherent regions of the same color, and we can compute labels for them. And this is the value of the labels of each of those blobs. The background blob is number 1, and within the background there are 3 top level objects, and they are blobs 3, 2, and 6. We can consider that these blobs are children of the background. The foreground objects are children of the background object. Now, object number 3 has got 2 holes in it, and we can consider these holes as children of blob number 3. So we're building up a bit of a family tree here. 1 is the background, it's got children 3, 2, and 6. 3 has got children 5 and 7. 2 has got 1 child, which is blob number 4. And blob 6 has got 2 children, 8 and 9. Now, 9 is a bit more complicated. It's a hole, but within that hole are 2 white objects, regions 10 and 11. So we can build up a family tree of objects, a blob hierarchy. Let's try this out. I'm going to load the image that we were just looking at. It's in the file multiblobs.png, and we can display that just to verify the image that we're looking at. And now I am going to compute a label image as we did a little time ago. I used the iLabel function, pass in the image. We see that NB has got a value of 11. There are 11 unique blobs in this particular image, and we will display the label image. Here we see the label image, and here we can see all the pixels that belong to blob number 1. All the pixels here belong to blob number 3. This blob up here has been labeled 5. This blob down here has been labeled 10, and so on. Now, we'll use again the iBlobs function that we used in a previous segment. And I'm going to pass in the original image, and the result is a vector of blob objects or region feature objects. We can see that there are 11 objects here. Now, there's some pretty interesting information that we see in the attributes of these individual objects. In particular, we have an attribute which is the parent attribute. So here, for instance, we can see that blob number 2 has got as its parent blob number 1. Blob number 1 is the large blob, which is the background. If we go and look at the information for blob number 1, we'll see that its color is 0. It's a black blob. We see it's got a massive area, so it's clearly the background blob. We also see that its touch flag is set to 1, and that means that it's a blob that touches the edge of the image, and it's the only blob that does so. So we can see, again, that blob number 2, its parent is blob number 1. We can also see that blob number 3 has parent, blob number 1, and blob number 6 has as its parent blob number 1. Now clearly we can see that blob number 3 has got 2 blobs within it, and we can see that blob number 5 has as a parent blob number 3, and that so does blob number 7. The situation is quite a bit more complex for blob number 6. We can see that blob number 6 has got 2 children, and they are blob number 8, its parent is blob 6, and blob number 9, whose parent also is 6. Now, blob 9 has got 2 children of its own, and they are blobs 10 and 11. So we're able to build up, if you like, a family tree, a hierarchy of blobs. At the top we have the background blob, then we have the 3 white blobs, blobs 2, 3, and 6, and each of those have children. We can represent this information, this relationship between the blobs, as a hierarchy or a family tree diagram, and we can represent it quite clearly and powerfully in a graphical representation.